Yep.
Okay. So today we are talking about parametric and non-parametric tests. Okay. Now, what we'll do is we'll try to understand different concepts first. Okay, because when we use a lot of terms, like this and like that, and especially in our textbooks, what happens is when you're reading, you're not able to follow it because it all looks very complicated because of the jargon that is being used, which is all statistical in nature. So what we'll do is we'll kind of like go one by one into different concepts, and then we'll go into proper parametric and non-parametric test. Prahash, next one, please. Rush. Next slide, please.
I'm trying whatever I can.
Yes. Okay. So now what you see over here is population and sample. See, where I'm starting from the beginning. So why we do using statistics is because we want to do some research. And when we're doing research, we can't use the entire population and do the research on all the people there. Like even if you take a small city like Bangalore, there are like lakhs of people there. And to just find something which is relevant to Bangalore, we cannot go and get data from everybody and do the sample. So to the test. So what we do is we do a random sampling, and we take a small sample of people to represent the population. Now, when we do the tests on this sample, what we are expecting is that whatever result we get from this sample we should be able to apply it for the population. So if I think the sample is having a certain characteristic or a certain parameter, then that parameter should be applicable to the entire population from which the sample has been taken. Now that is what the research is all about. Okay, next slide. Right. So when you say parameter, what does that word parameter mean? It just means that what are the characteristics that we are looking for in the population. See, for example, over here, we are looking at population of interest, that is adults in USA. That is the entire population. Now, what do we want to know about the population is a parameter. So I want to know what is the percentage of the adults in USA are married, or what is the average age of those adults in USA, or how many are older than 70 years old. Now, these are all certain parameters which I want to find out about the population. Right? And to find out that about the population, what I'm doing is drawing a random number of people as a sample, and then using the tests on that sample to find the parameter. Right? So that is so when you talk about tests, there are certain tests which are parametric tests and non-parametric tests. So the name of it is because of this. So if I'm able to use a test and able to determine the parameter of the population, then it's a parametric test. But if I do the test on a particular data and I cannot be sure whether that parameter works for that population or not, then it's a non-parametric, right? That's a simple concept of parametric and non-parametric. Okay. Next slide. Right. Okay. So when we start the research, so you've now drawn a sample and you're ready and you're going to start the research. Now, for the research, what we're going to do, first we have to have a problem or whatever is our the thing which we want to find out, right? We first have a problem, and then we make a hypothesis, right? Both null hypothesis as well as alternate hypothesis. But anyway, what is a hypothesis? Simply put, it's basically a statement that we make in the beginning of the research, which is yet to be verified. It's not proved yet, or it is not verified whether it is right or wrong, or it is not verified whether it is true or false. Okay. So in the beginning, what we'll do is, instead of complicating our head with lots of problems, what we'll do is we'll write one nice simple statement, okay, which is about the problem or about what test we are going to do. And with the help of the test, we are going to verify whether the statement that we made is true or false. That's as simple as that. That's what hypothesis is. Okay. So that could be a null hypothesis or an alternative hypothesis. I think we've discussed extensively in the previous classes about null and alternate hypothesis. Anyway, so now how do we verify whether the statement is true or false? Okay, that's where the tests become relevant. These are called tests of significance, statistical significance. Why? Because those are the tests which will tell us whether a particular problem is significantly true or not. You know, there is a significant chance of that problem, of that statement being true, or there is a significant chance of the statement being false. So that is the test of significance. Okay, next. Right, test of statistical significance comes in two varieties, like we already discussed, the parametric test and non-parametric test. Okay, so the tests help the researchers decide whether the hypothesis is true or not. But the point is, which test to be used? We can actually use any of the tests, but the point is why we want to use parametric or a non-parametric test. Next slide, please. Yes. Okay. So what is the purpose of doing a research? So when we test the sample, then it should be able to reveal parameters about the entire population, right? And for that, the test must be powerful enough for us to take the result of the sample and apply it to the entire population. So whatever result we get, that should be so accurate and so significant that it can be applied for the entire population and it should still hold good for that. So that powerfulness is what we are looking at, right? So if the test is able to do that, then it is called a parametric test. Okay, if the test is just giving us you know, a ballpark figure, or it kind of like, you know, is not so accurate, we still are a little not so sure about whether we can use the sample to understand the population, then it is a non-parametric test. That is like, till now I think everything is clear. Let's go to the next one.
Sunitha, one question. So are we saying that for reliability, parametric test is more useful?
Yes, correct. For reliability, parametric test is more useful. Okay, that reminds me, I need my notebook also. Just give me a quick sec, I'll run and get my notebook.
Okay.
Yeah, and the simple truth about parametric test is parametric test lot depends on the actual numbers. Whereas non-parametric test converts non-numbers into numbers to draw some kind of numbers. So in that way, parametric test is more reliable if we have numbers in hand, right? I mean, there are advantages of non-parametric, but anyway, I think Sunitha would cover in future. That is where the reliability part is coming, because it is actually dealing with true numbers.
Okay.
Okay. Right. Yeah. Thanks, Praveen. Please do pitch in wherever you know you feel relevant. Okay. Right.
Yeah. Shall I now go to the next slide?
Yes, please. Right. So this is the summary. Okay. So hypothesis, it's divided into null hypothesis and alternative hypothesis. And from for null hypothesis, we're going to do a hypothesis testing, for which we need statistical tests. And the test is divided into parametric test and non-parametric test. Okay, so this is like the summary till now. Next slide. Right. So we'll just understand a little bit about this. So about a few concepts before we go into actual parametric and non-parametric tests. So what we're doing here is we are collecting data. So step one of any research is what? Collection of data. But what kind of data have we collected? That's the whole deal, right? So data can be of two types, qualitative and quantitative. We understand by the name itself, right? Qualitative is something which is not measured in numbers, right? Quantitative is like proper measured in numbers, okay? But yet there are two other differences. I mean, there are four different types of data which come under qualitative and quantitative. Under qualitative, we have nominal and ordinal data, and under quantitative is interval and ratio. Could you go to the next slide, please? Right. So we'll talk about nominal. What are the different scales of measurement, right? So that's what is the different types of data, and how we have measured the data is the measurement of scales. Okay. Yeah. So if you see the first one, it says nominal scale. It's used to label variables in different classifications and does not imply a quantitative value or order. Okay, the definition is very fancy. I'll just I like the example given in our textbook, right? So like, you know, if you say if the data is classified, for example, a population is divided into male and female, so there are two labels given. Okay, now there is no order in the data, or there is no male is more better than female. There is no comparison or nothing. It's just label given to the data. Okay, so that's the one measurement, but then there is no numbers associated with that. It's only label. Next, what you go, that is the basic, okay, labels. Second, ordinal scale is used to represent non-mathematical ideas such as frequency, satisfaction, happiness, degree of pain. Now, if you see in all the examples that they have given over there, we are measuring something over there. But what we are measuring, there is some kind of measurement. There is some kind of order, like what comes first, second, third, fourth, like that, or, you know, what is, first best, second best, third best, like that. There is some kind of order there. There is some kind of a measurement there, but then whatever you are measuring, it is not quantifiable. It is more abstract. All right. So that is an ordinal scale. Okay, so if you have data like that, those two data are under qualitative, the nominal scale and the ordinal scale, they come under the qualitative type of data. And then next we have interval scale, right? Interval scale is, it's defined as a numerical scale where the order of the variable as well as the difference between these variables is known. So the next level, now we have a order and we also have a proper difference between each of the thing. Like for example, yeah, for example, these like, you know, if you have an order, I think 1 second please. Praveen, help me out here please.
What happened? Which one?
The interval scale.
Here,
So,
right?
Yeah, go on, Praj.
Oh, it's looking like the same. That's what you're saying.
Yeah.
Okay.
So basically,
yeah.
Sorry.
It's actually numbers here, right? You're asking for a let's say class. Class is an interval scale. Which class is a student studying in? It's 1, 2, 3, 4, etc. Right? So it has an order, and okay, I'm going wrong here.
It doesn't.
So
It doesn't have. So the thing is this. First one is it doesn't have any order. It does have only categories. Second one is it categorizes and it also has got order. The third one is it has got categorization, order, and also it actually, it does. Only thing, the difference between ratio and interval is interval scale doesn't have an absolute zero. That means it can even go in negatives.
Correct. Yeah.
So whereas ratio scale cannot go into negatives.
So there is an
yeah, correct. Height weight actually falls under ratio scale for that matter. Temperature is the right example.
Temperature is the right one. Yeah. Right. Okay. So these are the 4 types of data. The interval scale and ratio scale fall under the quantitative data. So we can do something with the numbers that they have given, right? So that is quantitative.
Sunitha, I think this keeps coming for questions as in a few times. So if anybody has any questions, you can take them.
Yeah, I have a question. In the image, it says for interval scale, it says very unsatisfied to very satisfied. Is that correct?
It's similar, but it's actually like numbered, right? 1 through 7.
There, right? That it becomes ordinal scale. again?
No. There you are just using smileys over there to depict your thing, right? Okay. Very satisfactory. Satisfactory. Okay. Neutral. Dissatisfactory. Not so satisfactory. Now here we are using these kind of abstract terms. Here what you're doing is we are rating it from 1 to 7. So we are having numbers and we are rating it based on whatever satisfactory level, but we are basing it on numbers. So it is something quantifiable.
Yeah, only thing about that particular example is it is causing confusion, because what is happening is the true nature of the data is not an interval scale type of data. Actually, the true nature of this data, like satisfaction, you cannot actually consider it as a true numerical value, but it is rather converted into a interval scale. But actually speaking, I mean, easy example could be something like temperature, where it is truly a numerical value for that matter, right? So yeah, right. I mean, this is bit of overlapping because the true nature of the data satisfaction is not really falling under the numerical scale. But it is like converted into numerical scale so that it can undergo certain operations like multiplication or whatever that you would want to call. Right?
Correct.
Okay. Okay, understood.
Don't get confused by the example. The only thing is that interval scale means, like the name itself says, like interval, there is some interval between two samples in the data, right? There is some difference. So that is measurable for us. Okay. So go by the
and it doesn't have absolute zero.
Yeah, I think if confused, I think that variables related section within RM, which is research methods one. In that wiki, there are actually few things that are mentioned over there. Probably just can be referred back again.
Okay, sure.
But order is this. I mean, first is nominal.
Fine. That's why I was proposing the example of which class your child is studying in. So it should be 1, 2, 3, or 4, or something like that, right?
Yeah, correct. That also works because there is an order to it. There is an interval between the classes. Okay, and the differences we can actually we can measure the difference, right? So it actually falls under intervals.
But actually, then how about absolute zero?
Sorry,
there's no absolute zero.
How about absolute zero?
You can go to KG standards as -1 and -2. I'm like, for example.
Actually, absolute zero is absence of.
Correct.
Sorry, go ahead.
Yeah, so in that way, yes, the class example really falls under the ratio scale, because
yes,
because there is an absolute zero for the classes. So the difference between interval and ratio is that only. That is the critical difference.
That the ratio scale has an absolute zero, and from where actually proceed forward, right?
Yeah, correct. I mean, anything which can go into minus, that falls into interval. If we can't go into -1, -2 classes, then it is not really classifying it as an interval.
Okay, that makes sense.
Yeah, that makes sense. Yes. Okay, then. So these are the 4 types of data. The nominal and ordinal scale go under the qualitative data. Interval scale and ratio scale come under the quantitative data. Okay. So next slide. Right. So then I would like to touch upon normal distribution and skewed distribution. Now we will have a separate class on normal distribution which talks about all it in detail. For now, if we understand that in the normal distribution, this is the kind of a curve that you would see, the normal probability curve. Okay, so in between is your mean. And then there is this -1.96 plus 1.96, that is your kurtosis, and then you have -258 plus 258, which is your skewedness. Now all data should come inside this curve, right? And most of the data that you have collected will fall in the middle line, which is like towards the mean, right? That would be your what you call the central tendency of the entire data, and it will be the mean, median, and mode will meet in the middle. So that is a normal distribution. On the right side, if you see, it's a skewed distribution. Some of the data is either too much on the right side, so it's negatively skewed, and some data, most of the data is on the left side, which is like positively skewed. But here, if you see, the mean is in the middle, then the median is in a different place, the mode is in a different place. So they are not actually, it is not a normal distribution, right? So when we have a data or sample that we have collected, which actually works with, which forms the normal distribution, now that is the data which we can use for parametric tests. Okay, the data which does not make a normal distribution curve, normal probability curve, we will be using non-parametric tests. Let's go forward to see the next slide. Right. So basically, the difference is that for a parametric tests, we use interval and ratio scale data, which is much quantifiable and measurable. And for non-parametric tests, that it's the other way around. If we have a data which is under ordinal or a nominal scale, then we use a non-parametric test. But if we have a data which is quantifiable and uses the interval or ratio scale, then we use a parametric test. Okay, if the data is the number of sample is very large, then it makes sense to use a parametric test. But if the sample is small, we can still use a non-parametric test. Now, why we say if the data is small, we can use non-parametric is, like, you understand that the ordinal and the nominal scale has a lot to do with the order, the ranks and all that. So if we have too many samples, too many number, it's going to be a very tedious job to rank it, right? Rank it, number it, and do the process. So when there is larger number of samples, it makes sense to move on to the parametric tests. Okay, then data should fit a particular distribution, that is the normal distribution. Okay, so the data should be in the normal probability curve. Then we use parametric tests. But if it is not so, then we can utilize the non-parametric test.
I have a question here, Sunitha. Yeah? See, if the data is of the interval kind, since it is numbered, see, nominal and ordinal will just be red, green, or satisfied or unsatisfied, or not in between satisfied and unsatisfied. Yeah, it will be like one of those. But what if they are numbers? Then how do you use non-parametric tests? Because actually it's numbers and you can order them, and they might even have an absolute zero. So then how can you use a non-parametric test?
Non-parametric tests can be used on all types of data. Okay. But there is a reason why we use parametric tests. I'm coming to that. Okay. Non-parametric tests can be used on all types of data. There's no question about that. The point being that the one is for the sample size. When it is too much, it becomes very tedious, right? And apart from that, since the when we come to that slide, I will tell you.
And to tell here, Madhavi, the thing is like this. There is one statement which Prayas has told, which Prayas has asked before, right? Which Sunitha has made, saying that parametric tests are more reliable. So if you underline that, so our first choice, if we can do parametric tests, we would want to do parametric tests. Okay, so non-parametric test will come into picture only when I can't do parametric tests. Okay, so there are certain conditions under which the parametric test is not a possibility. Hence, I would go to the non-parametric test. So anyway, those conditions, Sunitha would actually tell under what conditions non-parametric test would actually come into picture. So it is not about you can't conduct non-parametric tests when you have a numerical data. You can conduct, but when you can actually come up with more accurate test, why would you want to actually do an inaccurate way of doing it? Hence, you will always prefer, if it is possible, I'll do parametric. If it is not possible, then only I'll go to non-parametric.
Okay, just one quick question, last one. It says that parametric tend to need larger samples. If you have a smaller sample, you don't really have a choice. Is that what it says? You have to use non-parametric on small samples?
Yes, exactly.
You cannot
If you
use
have a
parametric.
if you have smaller samples, then yes, you are like, you don't have a choice of using
Test.
parametric test. Rather, you
Okay.
will go for
Because
non-parametric.
like the reliability is all about that, right? The more you have in the sample, the better is the accuracy of the parameter that you receive, which can be applied for the entire population. If you have a population of 1,000 and you have only 5 people for sample, whatever result you get from that is like, I don't know if we can apply it for population, the entire population of the rest of 995 people, right? It doesn't make sense. That's why it is more important for us to have a larger sample size so that we can rely on the test that we receive from that sample and apply it for our, larger population. All right. Okay.
Yeah.
So that's what it
Sunitha,
means.
just
What do we mean by data?
one more question.
Only one.
Go ahead.
Shall I go ahead?
Yes,
Yeah, go
please.
ahead.
Yes, please.
So in for us in the exam, right, do they just give data? Is it? I mean, have there been questions? I've not looked at all the question papers. Do we have to plot, check if it's fitting in the normal distribution curve, and then pick a test? Or generally, do they give just perform this analysis and with the
So
data?
Yeah. See, like Prahesh, go back to that normal distribution slide, no? See, now we don't need to plot this in a normal distribution or any such thing. Okay. So, like I said, when we compare the means, parametric test is all about numbers, right? All sorts of statistics become available to us. So when we talk about means, standard deviation, correlation, so what are all these? Are nothing but getting some data out of from the data we have found out a statistic, right? So when you have those kind of things in the question, then you know that it is a parametric question. Okay, but as per our thing, most of them they are asking the name of the test. They don't usually tell you that you have to they give a data and find it yourself, kind of. They don't do. Most of the tests they tell you what test you have to apply. But for example, if you have a lot of like mean, standard deviation or correlation, all these statistics, if they are given in the question, then you automatically know it's a parametric test. Okay. And if there are percentages, proportions, things like that is given, then you know that they are non-parametric tests because they are very vague. Percentage of people are diabetic, or the proportions as the proportion of diabetic people in the population was so much. So this is like they are not absolute numbers. They are percentage and proportions. Then you know that you have to use a non-parametric test. But mostly in our question paper, they ask you what is the test that they want you to perform on the particular thing. Okay.
Okay.
So
And in
I have a
actual
question.
research, just 1 second, sorry. So, but in an actual research, just calculating median mode, not actually plotting the curve, we should be able to figure whether it is normal distribution or skewed. Right?
yeah, when
we don't
we
have
do
to actually plot.
distribution class, we'll talk extensively about that. We'll be doing that on Monday only. So we can do extensively on that. Okay.
Thanks, Sunitha.
Yeah. Somebody else was trying to ask something.
Yeah, no. Can you just go back to the slide where you were showing the differences? I just the previous one. No. The one where you had comparative. Yeah, this one. So what do you mean by data should fit a particular distribution? I don't quite understand that.
That is the normal distribution, right? The data should be in the normal distribution format. That means most of the data should be converging to the middle,
Okay,
right?
got it.
So
Okay.
it will be converging, central tendency will be there. Everything will be converging towards the mean or median or mode, which is in the middle, right? And the rest of the data will be on the sides. So between those two things, that minus 1.98 and plus minus 1.96 and plus 1.96, major part of your data will come inside that, right? So that would be a normal distribution. There will be a central mean, and this would be the kind of curve you will get when you plot that kind of data in a graph. All right. So that is the distribution. If the data is like this, that means averages, most of the averages are 1. That means that the data is normally distributed, and that means we can use parametric tests on it and use the whatever result we get to formulate the parameters about the entire population. Right? It goes that way.
Okay. And left skewed means it's more towards the negative side, and right will be more towards the positive.
Left or right skewed, in either ways, what is happening is the data is not centrally its data is actually, the mean is different, the median is different, the mode is different. So there is no normality over there. So when it's not normal, it makes no sense for us to take the result of a sample and apply it for a larger population.
Got
right?
it. Okay.
So that is the reason we do not do parametric tests there. We will use a non-parametric test in its place.
So the thing that needs to be understood here, I mean, there is a separate class that is going to that is going to come on normal distribution as such. In that, skewness, kurtosis, and other things would be talked about. The basic point that needs to be understood now is about the sample or population, whatever that we have taken, needs to fit into the proper normal distribution. So if it is skewed or having some errors, the parametric test, parametric test would not be accurate.
Understood. Okay.
Right. Okay. Let's move forward then. We go back. Yeah, go back to the previous slide, please. We'll just revisit the difference. Okay. So first thing is, like we all spoke about, interval and ratio. If the data is quantitative, then we use parametric. If it is qualitative in nature, we use non-parametric. Okay. If the data sample size is large, then parametric works. If the sample size is small, we can go with non-parametric. Okay. If the data is normally distributed, it has a normal probability curve, then parametric. Any other type of distribution, it's okay to do non-parametric. Okay. Samples should be drawn randomly from the population. Right. That is very important, so that it covers, different types of people in the population. Here, the samples need not necessarily be randomly selected. Okay. And parametric is more powerful. Why? Because of the reliability. So the test is having so many assumptions and conditions, right? So when you're doing based on this kind of a data, whatever we get as a result is strong enough and accurate enough to be applied for a larger population. And hence the researchers can rely on this test to predict anything and everything about the population. That is why this parametric test is more powerful. But non-parametric test can be applied on all types of data, but we use parametric tests because it is more reliable. And if you're going to spend so much time on doing so much of research and all the data analysis and everything, it is best if we can have the most accurate and most strongest level of significance. Okay, next one.
Can I ask a question? Sorry.
Yes. Yeah.
Now, let's say you get a skewed a graph. So obviously now you said you cannot use that data for a larger population, right? And you will have to use a non-parametric test. Why is it that you cannot use it? Maybe the data does not have to necessarily be wrong just because you got a skewed graph.
Correct. Right? So now what is happening over there is the data is not, see why we are using a mean. Okay, I think we'll talk about it in the normal distribution class, but the reason we are using a mean is if all the data has an average, right? When you average it out, there is a singular statistic that you're getting, right? The mean, the median, the mode are all converging into one thing. So these three statistics are just nothing but understanding how the data is, most of them are falling under the category. That is the answer. That's the thing.
What I'm understanding is that you're saying if we had taken a large enough sample and if we had taken the samples randomly and randomly enough from the population, then we should always get a normal distribution. Is that
not necessarily?
No, so then
not necessarily. The
Okay.
reason being, now I took a sample, say Bangalore, we took a sample. Okay, for want of a better example, if I take a lot of people from North Bangalore, there'll be a lot of Telugu speaking people, right?
correct.
If I take a lot of sample from South Bangalore, there'll be a lot of Tamil speaking people. Right, in middle probably a lot of Urdu speaking people will be there, and on the west side there will be a lot of Kannada speaking people. Now if my sample is not random all across Bangalore, what I will get is a skewed distribution, right? So if I use a lot of samples from North Bangalore because it's near my house, then what happens? My distribution becomes
that
skewed.
case it makes sense. But let's say
Right?
age, there's a much younger population in Bangalore. So let's say you take age wise, you get a skewed thing because you get so many more younger people and much less older people. Does that not mean that your sample is wrongly taken? It still means that is the way the representation is of Bangalore, a younger city, a younger town. Let's just say that's the case. So then now, is that so? How can then in that situation you
Then in
cannot
that
say
case
that
also,
your
your
graph is
data
wrong,
will be
right?
centrally tended towards age in the middle. The average age will become a particular mean, right? See, it will not become skewed. It's just that the average age will move out into one side, right? That will become your middle, and then the data will be what do you call that? Yeah, when we talk about normal distribution, we'll talk a lot of terms. That time we will understand how the difference between, the normal
I get it. But you're basically saying that it will always have to have a normal distribution if it's correctly taken your sample.
Not necessarily. If the data has a normal distribution, it's good. So we can apply it for the population. That's all.
Okay.
It depends on how you define the population sample, I guess, right?
Sorry?
No, it would probably depend on how you define the population sample.
How you collect the sample exactly.
Define the sample, the population sample.
Right.
It depends basically on the hypothesis on what you are trying actually.
Okay. Okay, I think we need to more discussion on this. So let's move on.
Yeah, let's move on. Right. So now that we've determined parametric and non-parametric, we'll talk a little bit about the sample also. Okay, the different types of samples. So and then we will talk about what type of tests we can use for what type of sample. Okay. Now the sample types are paired, unpaired. Okay. What are paired ones? Is nothing but we are doing comparison between the same group. That is something before and after an intervention of the same group. Okay. Unpaired is there are two different groups and then there was an intervention and we collected data before and after the intervention. I'll give you examples for it. And then of course Anova, which is nothing but comparison between data across multiple groups. So one group before and after data is paired. Two different groups and then we have two different before and after, that would be unpaired, and multiple groups and then comparison between all the data is called Anova. Okay, let's go to the next one. Right. Okay, pair tests are okay. You can go to the next one. I'll come back to this. Right. Okay, so now the data are this the samples are bifurcated into paired, unpaired, multiple groups, relationships like that. But for each of this type of sample, we have parametric and non-parametric tests. Okay, so if for a paired or unpaired, for paired or unpaired type of samples, we can use t-tests. Okay, and on the right side we have non-parametric tests which is relevant to the same data. For example, now if it is a paired test, that means group A was there. I mean, there is a set of students, and before first they measured their weight, and then they gave them some kind of pills, and afterwards they measured their weight. Right? It is the same group of people. So we have before data and after data. So it is called paired. So by pair, it means it's the same people. Okay. And we can do t-test for that for that parameter. For parametric test, we can use t-test. Okay. And for the same paired data, if it doesn't fall under the assumptions of parametric test, we can use sign test or sign. It's all the same: sign test, sign rank test, or Wilcoxon test. Okay. Then again we come to unpaired test. That means there were boys, then there were girls, and then they took the average weight of the boys and girls, and then they introduced an intervention, a drug, and then later on, after the drug was used, they give you they take another set of data, like they take their weights after the drug was used. So this is unpaired data. Two sets of data or two groups of people were used, so they are not interlinked. So there are two groups of people. Again, t-test can be used with a little variation in the formula. And if the parametric test is not applicable, like we discussed about all the assumptions that we have to do, then we can use a Mann-Whitney U-test for unpaired data. Okay. Then multiple groups. So if we have a lot of groups of data and we are trying to compare amongst the different groups, then we are using Anova. Okay, it's a one-way Anova analysis of variance. Okay, that is Anova is a parametric test, and the equivalent non-parametric test for comparison of multiple groups is your chi-square. Okay, and then relationship, that is relationship between the variables. For a parametric test, we use Pearson's correlation coefficient, and for the equivalent of it for a non-parametric test is the Spearman's correlation coefficient. Okay,
and
so yeah.
And at this level, I think the only thing that we need to point or note here is, so basically there are parametric tests and non-parametric tests like defined for each category. So whether it is a paired test or whether finding the relationship or finding with multiple groups and all those stuff. So you don't really have to remember the names of these particular tests, because anyway we are going to go through what is chi-square, what is Anova, what is t-test. So when you actually know what is t-test in detail, you can automatically categorize whether it is a parametric or non-parametric. So automatically you would be able to remember this particular table while you actually go through those algorithms in detail down the line. So the thing is, there are parametric tests, there are non-parametric tests for every type of problem. That is exactly what is being told here.
Every type of data, every type of problem, we have two types of tests available at our disposal. Depending upon what kind of strong data we have, we can choose a parametric test. If we are not so lucky, we can choose a non-parametric test. All right, let's go ahead. I hope that paired, unpaired and all is clear. Otherwise, I'll revisit the example a bit later. Okay. So, Prahash, can you just go a little bit forward? I just want to see the slides that I have. Okay. Right. Go up. Yeah. I'll just go to that example. Just go to the last few slides, last two slides. Yeah, here. Okay. So just for the same example that I told, I thought I'll just brush it up once again. So paired is comparison between the same group before and after an intervention. For example, a new drug for weight loss is being tested among 10 patients. So first, the mean weight of before intervention was 100 kg. Okay, intervention of the drug is used for about 3 months. Okay, after the 3 months, now the mean weight of the patients after the intervention became 60 kgs. That means mean weight means most of them had a mean weight of around 100 kgs. And after the drug was used for 3 months, most of their weight was around 60 kgs. Okay, so that is the mean weight. So what has happened is we have data for before the drug was used and after the drug was used, but the same patient's data. Okay, so that is two sets. So same 10 people were tested, but we got two sets of data that we are comparing to either accept or reject the hypothesis. That is your paired test. Okay, go to the next slide. So unpaired is using the same example, two different groups before and after an intervention. Okay, so same example, instead of 10 patients, we are using 10 boys and 10 girls are being tested. Okay, so now if you see there are, so n is equal to 10, boys n is equal to 10, girls n is equal to 10. The mean weight of the boys was 160 kgs, the mean weight of the girls was 120 kgs. The same intervention is given for both of the groups. The drug was used for 3 months, the drug was used for 3 months. And after the intervention, the mean weight of the boys reduced to 110 kgs and the mean weight of the girls reduced to 100 kgs. So now we have now 2 sets of data, and both of these are from 2 different groups. Okay, and now we are which are not paired. They are not the same. They're 2 different groups, so unpaired. Okay, but we are utilizing this data to compare and come to a conclusion. Okay, then Anova is used to compare mean in more than 2 groups. So 3 to 30 groups, you can utilize Anova. 3 or 30 doesn't matter. Okay, you can use Anova. Now, if you say, for example, comparing mean historic BP of patients in multiple wards. Okay, multiple wards. So there are multiple different wards in the hospital, and they're taking the BP of all the patients in different wards and they're comparing it. So that means we have multiple set of data. Then we use Anova, which is more than 2. Okay, so that is about this. Let's go to the previous slides. Yeah, assumptions, yes. Okay, see now whatever we have discussed is actually the whole matter in this chapter. All right, so if we call it assumptions, advantages, disadvantages of parametric, non-parametric, all this is nothing but beating around the bush and saying the same thing all over again in different formats. Okay, so basically when you are saying parametric test, what are the assumptions? The assumptions were, when we said difference between parametric and non-parametric, that exactly is the assumptions of a parametric test. Okay, the tests are based on the assumptions about the population. The distribution should be normal distribution. Okay, so interval or ratio level data, right? We talked about it. The data should be normally distributed. Okay, and the variance, the standard deviation squared should be similar in each group. So that is also a part of normal distribution. Okay, and the random sample should be random. So the same, whatever we say as difference between parametric and non-parametric is actually the assumptions of parametric tests. Okay, and the assumptions of non-parametric test is that there are no such assumptions. Any data you give, we can do non-parametric tests on that. All right, next one. Okay, so advantages of non-parametric methods. So we are asking why we need to use non-parametric when parametric is powerful, when parametric is like, is so good at predicting the future or predicting the population's parameters, then why should we even use non-parametric methods? It's because not all data will be normally distributed, right? We will have a lot of data which is not. So then these tests will become our aid when we have to utilize those data and actually come to a consensus, come to a result. Okay, so they can be used to test population parameters when the variable is not normally distributed, the data is not normally distributed. They can be used when the data are nominal or ordinal in nature, and they can be used to test hypotheses that do not involve population parameters, wherein, when all data need not be a sample, and with all data need not be like, I have to go and apply it for a larger population. It needn't necessarily be that case. Then why should we take the trouble of doing the parameter test? If it's only, I'm only going to be worried about the 10 boys who are, the 10 patients who are going to be tested. I am not going to take that and apply for the entire population and say, because these 10 boys lost weight, the entire population can lose weight. No, I'm not interested in the entire population. I'm only interested in the 10 patients or 10 boys who have taken the drug and whether whatever result has come. So then in that case, there is no need for that kind of a parametric test to be done. Non-parametric works well. Okay, then in most cases, the computations are easier than those for the parametric counterparts. You all must have already seen in our classes the kind of formulas we use. The means have to be found, the differences have to be found, the formulas, the deviation, the correlation. Lot of statistics has to be found and then used in a formula to actually do the parametric tests. So the computation is extensive as compared to a non-parametric test. So why should if non-parametric is good enough, then we need not necessarily go and do the complicated computations. So non-parametric test is that way advantageous, and they're easier to understand, simple and easy to understand. Next, the disadvantages, like I said, it's all the same details, but when they ask you like this, you kind of you will change it according to the question that has been asked. But the details are all the same. Okay, so disadvantages of non-parametric method is that they are less sensitive than the parametric counterparts when the assumptions of the parametric methods are met. Therefore, larger differences are needed before the null hypothesis can be rejected. That means what? We know that reliability is the key in parametric tests, right? So if the reliability is not there, then on what basis are we actually rejecting a hypothesis? Based on a non-parametric test. So the difference or the significance should be so extensive that hypothesis can be rejected, right? Then only we'll be able to reject that hypothesis based on a non-parametric test. Okay, even if in a parametric test, even if there is a small significance difference, we are okay to reject it because accuracy is that level. But in a non-parametric, we cannot be sure. So the difference should be really huge for us to rely on it and reject the hypothesis. All right. They tend to use less information than the parametric test. For example, the sign test requires the researcher to determine only whether the data values are above or below the median, not how much above or how much below each value, right? So they are not actually calculating the weightage of the data. They are calculating the position of the data over here. Okay, so then it is using lesser information. So what the result we get will also be only so much. Okay, they are less. Okay, go back please. They are less efficient than their parametric counterparts when the assumptions of the parametric methods are met. That is, larger sample sizes are needed to overcome the loss of information. For example, the non-parametric sign test is about 60% as effective as its parametric counterpart, the z-test. Thus, a sample size of 100 is needed for use of sign test compared with a sample size of 60 for use of z-test. Okay. Now, what they're saying is that when the sample, now when you have a small sample and yet we want to, when we want to use non-parametric test for a particular sample and yet we want to apply it for the population, right? Then we have to have a larger sample, so that we can be sure that the sample, the result of the sample is okay to be applied for the population. Right? But if it is a parametric test and if the data is normally distributed and randomly sampled, then even a smaller sample will show more accurate and will be more reliable to actually take it to the population. So for a non-parametric test, if we are doing, we need to actually do a lot more, use a lot more sample to use the same test to apply to the population. Okay, something like that. And ranking the data. Okay, for many non-parametric tests involve with the ranking of data. That is the positioning of a data value in a data array according to some rating scale. So imagine if I have so much of data, if one side I'm saying I need larger sample so that I can rely on that result for the population. But on the other side, imagine taking that larger sample and then ranking it from beginning to end. It's going to take a lot more time and effort to rank the data, and it's going to be minutely, you have to look at it and you have to rank it. So that is going to be a disadvantage for a non-parametric method. Okay, the next one. I think that's about it. So that's what I've got, people. So the entire chapter is all about how we choose to do our research. Whatever data we get from one point to another, how do we go and choose a particular test and continue to do it. So if we go back to the beginning slide, one second, Prahash, go to the beginning where I was doing some one more, go back. Back. Yeah, no, yeah. So this is the whole story of how we are doing our research. For a population, I want to know about the population. So I decided to take a random sample out of the population. And now I made a hypothesis, a statement about the population, which I need to be verified. So that to test that hypothesis, I'm going to use some statistical tests. These statistical tests are divided into two types, the parametric test and non-parametric test. If the data is of quantitative in nature, and then I will go for a parametric test. If the data is normally distributed, I will go for a parametric test. If the sample has been randomly taken, I will go for a parametric test, right? And parametric test has, since it is all taken from with so much of assumptions are fulfilled, and then only I do the test. That is why the parametric test is much more reliable, much more powerful, and any result received from a parametric test of a sample can be taken back and applied on a larger population, and we can utilize the result of a sample to predict other things about the population. Okay, but in case we don't have all those assumptions, like if the data is not normally distributed, or if the sample is not randomly collected, or if it is the scale of measurement is what do you call, ordinal or nominal, or the sample is too small, then we might as well use a non-parametric test. That one will help us calculate it in a much easier way, in a much simpler way. But the fact remains that when it comes to reliability or accuracy of the test for application of a larger population, it definitely doesn't stand strong or as strong as the parametric test. So if you have the data which is good for which has all the assumptions, then we might as well go for a parametric test, because of the assumptions, our result is much stronger. So that is the end of the story.
Sunitha, one question. In the advantages and disadvantages section, right? Where non-parametric can be used where the research is actually testing the hypothesis, and it is actually not generalizing to the population. So that refers to mostly on the exploratory kind of research. Is that the right understanding?
Also be that could also be that. There are multiple places where we actually are not interested in a whole population, or the whole population is so small, right? We are not going to apply it to a larger population. The entire population itself is so small. Like if you're taking a particular, say that, the population, what do you call that? The entire population itself is only 10 people, or entire population itself is only 30 people. Right? If it's a tribe in a jungle, there will be only so much population. So I can test everybody. I can collect data from everybody, and
Alzheimer's patients of 30 years old.
Yeah, so I can. Their number is so less that it is okay for me to collect data of everybody. In that case, whatever result I get out of it is good enough, right? I'm not going to apply it for a larger population. So, in that case, the non-parametric method is okay.
Okay, and another question. So, is there a difference between, like, if we measure mean versus median for the test statistics, right? Is it going to be, is mean more powerful than median for the test statistic analysis? Also, because I was reading in one of the differences, right? It says that non-parametric uses median for usual measure of tendency, and parametric is mean.
So now
So,
mean is what you're doing. You're taking the all the data and you're averaging it out as mean. Okay. But in median, you're taking only the position. Right? Median is position based. Okay.
Right.
Like in that, if you see in that disadvantages, it is also written over there that if the it only worries about whether this data is coming one before or one after. It is not worried how much before and how much after. Okay. Say for example, now I have a list of now the ranks are there. There are 10 people. Me, okay, or just me, Prahash, Praveen, and Seema are there. We all write our exam. Okay. Now they have told that since it's my example, I will say I came first, then Seema came second, then Prahash came third, and Praveen came fourth. It's obvious he won't come for fourth, so still we'll utilize it for our example. Okay, so now we are saying over there that the median position, okay, we'll use one more person. What do you call that?
You can use me as fifth. It's okay.
Yeah, sorry, I can't see you, so I don't know who's talking.
Archana.
Kanchana, Archana. Archana, okay. So now Archana is...
Okay, before we go ahead, can I stop recording?
Since we started this explanation, let's finish it now so that they don't feel a little funny. Suddenly, beach mein cut kar de. Okay. So Archana is the number 3rd. Okay. Now here the median position is number 3. There are 5 people. The median is number 3. Okay, so then we are like, okay, Seema is has slightly better, has done better than Archana, and Prahash has done worse than Archana. We are saying, but the point is that Seema's score is only 55.5 and the Archana score is 55. Okay, and but from Archana's score to Prahash's score is 10. Like you're 55, Prahash is 45. Okay, so although it just looks like one position before and one position after, the actual difference in score, if you see, is Archana is it's not too much of difference. It's just that point by 0.5 you came to the 3rd position. But for Prahash, he is like 10 by 10 points. He's in the 4th position. So this weightage or this difference cannot be calculated in a median based thing, because only position is considered and not the actual difference in the thing. So it is not giving that much of weightage. So how good is that test? That's how it goes for.
Okay.
That's why median is position. So it doesn't have so much of significance as compared to a mean, which takes the total and then divides it by the number of people, and then we get the average. So that is a much more better statistic than median.
Got it. Thanks, Sunitha.
Yeah. We can stop the recording now.